Today, I wanted to talk in my sample lesson about the periodic table and the history of the periodic table. This comes from chapter 6, lesson 1 from my curriculum. And I just wanted to cover the first two objectives here, the early attempts to organize the chemical elements and how Mendeleev organized his periodic table, because it really just was totally out there. He was just this crazy Russian, and he made a lot of people crazy. So our early attempts at discovering the elements at 1700, we really only knew a handful of elements. And because there wasn't a lot of technology. When we hit the industrial age and we hit the pre-industrial age, like just before early 1800s, late 1700s, things just started exploding and we discovered so many more. Here is a periodic table color-coded by when elements were discovered. And you can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9 elements that we actually knew about. We had actually discovered before 1735. Between 1735 and 1843, that's all of the light blue. And you can pause the video now and peruse at your leisure, but we didn't really know that much all the way until the 1700s. As we're discovering these, we're realizing we should really organize these in a good way because this wasn't a thing. And so Dober-Reiner said, how about we arrange them in threes? And if we look in 1829, we see lithium, sodium, and potassium. They have similar properties, and we knew about 3 of them. And so, perfect example. Why not? Why not, right? Newlands gave this law of octaves that said, well, every 8 elements, then we repeat. 8 elements, then we repeat. Now, the big problem here is that we didn't understand what we didn't know. We didn't know what we didn't know. And there was no way for these guys to really understand that these laws are too simple. We need to go deeper. And then comes Dmitry Mendeleev in 1869, crazy Russian scientist. Look at that beard after all. And he organized in increasing atomic mass. And as he did that, he arranged in chemical properties that repeated periodically, he got this periodic table. Now there's 2 things here that really blows the mind. Is right here, tellurium and iodine, fluorine, chlorine, bromine, and iodine are arranged in the chemical properties. Tellurium and iodine are not organized in atomic mass. And because that was throwing everyone off. The other thing is that he left spaces. Element 68, so this is atomic mass 68, he called that eka aluminum because boron, aluminum, it's something like aluminum, like an eka aluminum. He didn't know what it was, but he put it in his periodic table because it should be there. And lo and behold, this is his eka aluminum. In reality, it's gallium. But he predicted that it'd be 68 mass. It's really 70, 69.9. He predicted its melting point would be very low. Its melting point is 30.15 Celsius, which is like, I could put it outside right now on a hot day and it would melt. He was almost spot on the density. He was spot on the formula of the oxide. He knew what this was without even seeing it in the first place. And that is what made his periodic table so brilliant. In 1913, Moseley defined the atomic number by the number of protons and arranged Mendeleev's periodic table by the atomic number. And that's where we get our current periodic table. By arranging the protons, not necessarily the atomic mass, which is what Mendeleev was doing in the first place. He already had that all in. So Moseley just reinforced the idea, and that's where we get our periodic law. When elements are arranged in order of increasing atomic number, like in the periodic table, there is a periodic repetition of their chemical and physical properties. And that is how we get our current periodic table.